Good af- good afternoon, everybody. My name is Gayatri. My course is on FC Sustainability. Today, I will discuss about the machine learning topic from fifth year. Today, topic is models in machine learning. At the end of the session, you will learn about problems solved by the machine learning and about the different models in machine learning. Coming to the problem solved by machine learning, in this we will discuss the what are the problems we are solving with the machine learning. Today we are solving by machine learning. First one is manual data entry and detecting spam and the product recommendation and medical diagnosis, customer segmentation and lifestyle predictions, also analysis and the predictive maintenance and image recognition. Coming to the manual data entry in traditional system, we are entering the data by manually. But nowadays, using only machine learning, we are solving this problem by with the help of machine learning. And the detecting spam means we are example from the Gmail from the mail. Some mails are uh, some mails are in spam. In that way, coming to the product recommendations. Uh, recommendation means we are buying products from online. Suppose we are buying any products, then some products are recommended for us. These problems is solved by the machine learning. And the medical diagnosis means we are medical diagnosis means the healthcare centers. Mostly we are solved by many problems by machine learning. And then image recognition means examples of face recognition and speech recognition. These are the problems solved by the machine learning. And then models in machine learning, the second topic, models from the central concept in machine learning as they are what is being learned from the data in order to solve a given task. I will discuss three groups of models. First one is geometrical model, probabilistic model, and the logical models. Coming to the basic idea of creating taxonomy of algorithms is that we divided the instance space by using one of three ways: using logical expressions, using the geometric instance space, using probability to classify the instance space. Coming to the first one is logical models. Logical models use a logical expression to divide the instance space into segments and hence construct floating models. A logical expression is an expression that turns a Boolean value. That is, Boolean means it is true or false or else or false like some outcome. Once the data is grouped using logical expressions, the data is divided into homogeneous group for the problem we are trying to solve. For example, for a classification problem, all the instances in the group belong to one class. There are three. There are mainly two kinds of logical models. They are tree model and rule model. Rule model consists of collection of implications or if-then rules. For a tree-based models, the if part defines the segment and then parts defines the behavior of model for the segment. Rule model follow the same reasoning. Models can see in a particular type of model where the if part of the rules are organized in tree structures. Both tree models and rule models use the same approach to supervised learning. Simple tree-based model shown in this video. Logical models and concept learning. Concept learning involves learning logical expressions or concepts from examples. The idea of concept learning fits in well in the idea of machine learning, that is, inferring a general function from specific training examples. Concept learning forms the basis of both tree-based and rule-based models. Formal definition of the concept learning is the inferring a Boolean value function from training examples of input and output. This is the concept learning task whether they are enjoyed sport or not. And these are the examples, and these are the attributes: the sky, air temperature, humidity, wind, water of the forecast. These are the attributes. And the enjoy sport, whether the person is enjoying the sports or not. These are the enjoys, but these are the cons, it is. And coming to the geometrical model, the geometrical model feature could be described as point in two-dimensional like x and y axis or in three-dimensional x, y, z axis. In geometrical model, there are two ways we could compose similarities. We could use geometrical concepts like lines or planes to define the instant space. These are called the linear models. Alternatively, we can use the geometric integration of space to represent similarity. In this case, points are close together. There is similar values for features in this the can as we call such models as distance-based units. Linear model. Linear models are relatively simple in case the functions represent linear combinations of discrete inputs. Thus, if x1 and x2 are two scalars or vectors of the same dimensions and a and b are arbitrary scalars, then ax1 plus bx2 represents a linear combination of x1 and x2. The simplest case where f of x represents a straight line, an equation of the is equal to mx plus c, where c represents the unit of m represents the slope. Distance-based models. As name implies, distance-based model works on the concept of distances. In the context of machine learning, the concept of distance is not based on merely the physical distance between two points. Instead, we can think of the distance between two points constant the mode of transport between two points. This is the management and the terrain. Traveling between two cities by plane covered less distance physically than the train become a plane unrestricted. Similarly, just the concept of distance depends on the phase used. For example, a bicycle can move diagonally. Thus, depending on the velocity and the mode of travel, the concept of distance can be expressed differently. A distance metric commonly used the Euclidean Manhattan models. Distance is applied to the concept of neighbors and explies. Neighbors are the points in a proximity with respect to distance measure expressed through explains. Are either centroid that find a center of mass according to chosen distance metric or periods that find the most centrally located data point. The most commonly used centroid mathematically, which minimizes squared equivalent distance out to all other points. These are the probabilistic model. We are familiar with the probabilistic like P of A by B equal to P of A by A, P of A by P of B. Already we learned in intermediate probabilistic. Probabilistic model sees feature and target variables as random variable. Here there are two types of probabilistic model, predictive and generative. Predictive model use the idea of conditional probability distribution P of Y by X from which Y can be predicted from X. Generative model estimate the joint distribution P of x, y, comma x. Now, by as an example of probabilistic classifier. Coming to the these are the glossaries, models from the central concept of the machine learning as is being learned from data in order to solve the risk data. Logical models are use a logical expression to divide the instant phase into segment. Hence, the construct grouping of models. From concept learning, we learn the inferring a Boolean valued function from from training examples of its input and output. Probabilistic model, see features and target variables as random. We will discuss next topic, the word process of function in next class. Thank you.